Hey there, folks. Welcome back to another part of my thing where I am making a robot Tetris announcer. Today, we are going to be continuing our efforts to make a transition analyzer, something that will recognize when a speed increase is happening in the game and is going to tell us when that's going to happen. We tried a few things last time. They didn't quite work out, and most of this stuff, I haven't really done any test-driven development because it's just been me plowing ahead with my own ideas. But I think for this piece of code, we're going to have to take a step back and write some unit tests just to verify that what we think is happening is actually happening, because what we want to happen is definitely not happening. So let's do that. I don't have any tests right now for the game analyzer, so let's make some. So we're going to add a new console application, and this will be called some tests. Yes, we want .NET Core 3.1. I could do .NET 5 these days, but I don't do that. The reason I don't do that is just because I've not gotten around to it. It's probably much the same. Okay, so now I want to take all of these things because I'm lazy and dump them into here. And now I've got them all. And this will become a unit test project, and I can delete this. Boom, yes, be gone. We're going to make a new folder for analyzers. And we are going to add a class for our transition analyzer tests. Okay. Now this has a little bit of a hiccup because you can only unit test. Come on. You can only unit test a public method, but if you look at transition analyzer, it is a child of the base game analyzer. And that has the public analyze method, which calls the child run analysis method, which is an abstract method which is implemented by every other analyzer. And so we can't actually run this thing. And because it's just a Boolean task, we don't have any return value to look at. So we're going to have to do some little bit of funky things here. What we're going to do is we're going to make a new, it'll be an inner class. Actually, you know what? Let's write our tests first. So we are going to write this test. Okay. For our transition analyzer, we need to lines are calculated. We're going to say lines until transition are calculated correctly. Okay. Now we're going to have some parameters in here. For a test for the transition, we need obviously a state model. But that's getting a little ahead of ourselves. The actual information we care about is the starting level, the number of lines we're currently at, and the number of lines we expect to be until transition. So that's only 3 integers. Let's do that. We can do that. Int start level. We're going to say current level. No, start level. Start level. Int current lines. int expected lines until transition. Boom, we're done. No, we're not. Okay, we're going to make some test cases. And each one of these test cases is going to provide 3 integers. So let's do this. Let's do some level zeros. If I've started at level 0 and I'm at level 0, no, my current lines are 0, then I should hit transition in 10. That's ridiculously easy. We're going to do a bunch of these test cases. Okay, if we're at 0 and we're at 5 lines, then we're going to do 5. Because we have 5 lines until transition. And I didn't do any spaces here, so let's put a space in all of them. Okay. If we're on level, well, let's go up a bit, 4, and we're currently at 12 lines. Well, we should hit transition at line 50, but we're at 12 lines, and so we're going to hit transition in 38 lines. That's easy enough. If we started on level 8 and we're at, so we did that, let's say 85, then we would expect to hit transition in 5 lines, because transition will happen at level 9, which is 90. Okay, so those are our, those are our simple cases, because the levels increase speed every level until level 9. So here we are. If we're on level 9 and we just started the game, so we're at 0 lines, transition is going to happen in, and that's what we can't remember. I know it goes to 10 at 110, I think. No, 130. Let's have a look at this page again. Hey, hey, hey. What in the world is happening? What? Didn't I? NES, there we go. It was on this website somewhere. Okay. Yeah, so the levels increase lines before level increase. You start at 9. At 100 lines, it'll go to level 10, which is a speed increase. Okay, so that's fine. So level 9, yeah, you should be 100 lines before a speed increase. That's fine. If you're on level 9 and you had here's one. If you started at level 9 and you were currently at 105 lines, this is interesting, because you already have been on level 10 now. So what you're really waiting for is a speed increase at 13. So 13 is going to happen. At 100 lines, you get to 10. 120 lines, you get to 12. So 130. 130, you're going to get to, yeah, whoops. So you're looking for 130 for your speed increase. So that'll be 25 lines. Hopefully we're not miscalculating anything here. Okay, if you're on level 10 and you just started the game, you will expect 110 lines until your next level, but no, that's not your next speed increase. Your speed your speed is the same from 10 to 12. So you're looking for level 100 or level 13, which will happen at 130 lines. All right. If you were on level 10, and let's say you had 179 lines, then your speed increase should be 1 because it's it should be 180 lines until you're on level 10. Total lines before level 29. Okay, that's fine. Oh, wait a second. Did I do that wrong? You started at level 10. So at 100 lines, you'll get to 11. 110 lines, you'll get to 12. 120 lines, you should get to 13, which is the speed increase. Okay. Let's forget about that. Let's do our ones that we know. Let's do some 15s. 15s, and you just started, we should see transition speed in 100. Let's do 15, and we are at 90. We should see 10 lines until transition. Oops. If we started on 15, and we were at 105 lines, we should see a transition in 25 lines. I mean, this I just know. If we're at 15, and let's say we were at 135, well, now we should. That's why this becomes important. 15, we're going to 230. So transition will happen in 95 lines. Okay, let's do some 18s. Again, 18s is pretty similar, actually. It's all the same. It's all the same except for the first one. First couple. So if you were at 18, you're going to get a speed increase at 130. If you were at 90, you're going to get it in 40. If you're at 105, it's still going to be 25 and then 35. Okay. This gives us sort of a rough kind of a gauge at what's happening. I should probably flesh out the 9s more. Problem is I don't really know. So at level 9, you're going to get to level... Oh, it's going to be 190, I think, to your level 19 speed. So if you were at... let's say 150. Are we thinking we're 40 lines away from speed 19? 19 speeds? Maybe. Maybe. I don't quite know. I'm not that good. Okay, let's do this. I think this is a good enough test case to see what we're doing. So now we have to plug these into our analyzer, but we don't actually have access to it because I think it's protected. Right, the class is not protected, but the method sure is. And I'm not going to change the accessibility of the method just to test it. So we're gonna make a new test analyzer, and it is going to be a transition analyzer. And we are going to have a public task analyze. It will take a state model and oh shoot, nope, delete that. We're gonna add this. What did I call it? Current state. Oh, but then I was just calling it state. I remember. Let's just call it state. Okay. And this will just run base dot. Oh, it's not an analyzer test. It's an analyzer. There we go. Excuse me. Okay. So this is its constructor. Now we can run base.analyze state return. What is wrong with this? Cannot task to task. Oh, I want to run analysis, not analyze. Run analysis. There we go. Run analysis. Okay. So we have a public method now. What's the problem here? Sure. Okay, so now we have this run analysis method that calls the actual run analysis method of the transition analyzer. We're good. Okay, so let us make some things. We need a system under test test analyzer. We're gonna do this. We're gonna make a setup method. Come on. Oh, low down. Okay, we need to give it a fake text and a current game model. I wonder if no, actually that's fine. We don't need a setup and all this. That's fine. Okay, we need a game model. Our game model equals new game model, current game model, and we have a starting level of starting level. Start level, perfect. Okay, and then we are going to say await our system under test. We need a new test analyzer. We're going to give it a fake text queue, fake text, and the game model. And the thing is, what's fake text? We're going to generate this variable. Here it is, and we're going to call it wait a second. Did I not? I didn't get Fake It Easy installed in here. Okay, 1 second. What is happening? Ah. Shoot. 1 second, folks. I am going to do something here that you won't be able to see. Oops, don't see that. Okay, let's shut that down. Now we can do this. Dismiss. Come on. guys. Crap. What a stupid problem this is. I don't have my computer. No, not in DevOps. What's happened to my NuGet feeds? Okay, let's add a new one. Package source. This is embarrassing. Probably shouldn't have seen that. This is just too big as well. Oh, for crying out loud. Okay, well. Yeah. Okay, let's try this. No. For some reason, the VPN won't work. Hey, look at that. Okay, yikes, that took a while. I want this, please. Thank you very much. Probably doesn't have the ability to add packages while there's errors. Okay, install. Unauthorized? What in the heck is going on? What do you mean I'm unauthorized? All right, 1 second, folks. Okay, I don't know what's going on with my feeds, but that works. If I directly add it from another project. Okay. Well, that was weird. Okay, so I have a fake text queue. That's good. And we can do that. Now, we're going to run this analyzer. And we are going to run it. We're going to analyze the new state model who's got the... Now, the transition analyzer doesn't care about the previous state. It just cares about the current state. So we don't have to set the current equals new Tetris data model. Actually, we need a fake one of these because I think... Yeah. Ooh, I don't know if this is going to work. Here. Var data equals fake Tetris data model. Now, that might... I'm going to do some debugging here because I'm curious about what this is actually going to do. Let's not run all these tests. So you can see start level is 18, current line is 135 and 95, just these three pieces of data. I'm going to create the game model. We're going to create the analyzer. Now we're going to try and create this. And it's going to fail. And the reason it's going to fail is because it can't create a fake type. Oh, right. We need a... shoot. We need a Tetris... Oh, boy. Let's go to our Tetris data model. This might be a little more work than I thought. We need all of these things when we create a Tetris data model. So that's okay. We can set this up. We can absolutely set this up. Okay, so we're going to make a Tetris data. Actually, we have a Tetris data model factory here, which creates Tetris data models for us. And that just takes these three things. Okay, so we need a screen reader, a color checker, and a screen information model. And we're going to need fake ones. Screen info. We actually, it doesn't really matter. This one doesn't have to be a fake one. It's just a... We can say game positions equals new rectangle. That's fine. Screen positions equals new screen positions. I think the screen positions... I'd like to actually make these things. See, it doesn't matter what the numbers are. Uh-huh. Does matter when I'm in here and I want to get the lines. It's very important that the lines rectangle in the positions is an actual object that I can reference. So we do need a setup class. Whoops, these things need those. New rectangle. You know what I could do instead? Here, let's do this. This is not that bad. We can just say new rectangle here. There's nothing wrong with us doing this. Digit recognition settings is a black. Okay, so that's fine. Now we can just make a new one of these things. It's new screen information model. I don't care about the numbers. That's okay. Okay, now we don't need this setup. We only have one method. So now we can say a new Tetris data model. We don't really care about the bitmap itself. So actually, I wonder if I can just say a dummy. Dummy. Can I do that? How do you do that? You can do that. I'm certain of it. I don't use dummies very much. Hmm. Dummy bitmap. Okay, we'll see if that works. We also want to give it the screen. Oops, the screen info. No, this is the screen reader. Screen reader. Screen info, and this is the color checker. Boom, done. Okay, let's see if we can get to this point. I'm not sure. I don't use dummies very much. I can never remember how to use them properly. What's the issue? Yeah, okay. So we can't use a dummy. Okay, so just a new bitmap. How's that? Can I do that? Oh gosh. 0, 0, stride. Okay, 0 pixel format. Who cares? Don't care. Haha, there's the don't care. And a pointer to an integer. You've got to be kidding me. What? Oh my goodness. I can just say this. Do that. Okay. Can I do that? Please just let me do that. No, you can't do that. What's the problem? Parameters not valid. You can't do a 0 by 0 bitmap. Come on. Mm-hmm. Thank you so much. Okay. So we got in there. So now we have to set up our screen readers and screen info and color checker to do things. So we're interested in getting the number of lines and getting the level, right? In our Tetris data model. So lines, we need to make sure screen reader.get value at this produces our lines. So this is what we want to set up, this call. So we're going to use call to, and this is what we're trying to do, a call to our screen reader. And you know what? I should really, oh, we can add read-only modifiers to all this. Sure, let's do it. And what I didn't do, which I usually do, is I call these things fake. Just so we know they're fake. This is actually not fake, but this is fake. Okay, so a call to the fake screen reader where we try to get the value at our yeah, we don't really care. So bitmap. Who cares about what the bitmap is? Oh shoot, is that, oh no. Screen positions, a rectangle. Is a rectangle a struct? Ah, it is. Equal location and size. See, the problem is if the rectangle has the same size, they're going to be equal because they're structs. And so we can't actually say, hey, did a call to try to get the rectangle bounding the lines or the level take place, because both rectangles are 0. Unless it does object. You know what? Let's actually hold on. Maybe it's fine. I don't know if it does equality checks. It might not do equality checks. Nah, it would do equality checks. Okay, what we're gonna do is this. We're gonna say screen info. Okay, var screen info equals. So what we're gonna do is we're gonna make the screen positions equals new screen positions. And we're going to do the things that we care about. Level is a new rectangle. That's a 1 by 1. And lines is our new rectangle. Is a 2 by 2. Oh, I see. 0, 0, 1, 1. All right. Okay. And this is 0, 0 by 1 by 2 by 2. Just so that they're different size rectangles. Just so that we can differentiate them because they're structs. Stupid structs. Okay, so now we can actually say a call to the fake screen reader where we get the value, any bitmap, but now we need a rectangle. So when you're actually screen info dot screen positions dot level, and then when we get the level, we're only asking for 2 digits. Doesn't really matter. Okay, so when you make a call to that, now you're going to return an integer, and it's going to be the we don't even need the level. What are we talking about? Well, the current level. The line should dictate the current level, right? Who cares until we... Yeah, we don't need the level. There. When we read the screen to get the lines, oh my word, we're going to return the current lines. Okay, that's all we care about. And now we have our game model, we have our system under test, we have our data. Okay, so let's bring this down here. Actually, because of that, we can even say this. We only care about the lines. Lines equals new rectangle. 0, 0, 1, 1. screen positions equals new screen. Lines equals that. Good. Now we can actually just use that. Which we already were, so it wasn't going to work anyway. Okay, so we set up our call, we set up that, and now we're going to wait sut dot run analysis. Oh, we need a yeah, no, that's fine. We need a new state model whose current equals data. That's all we need. Okay, so now we've run that. That's just going to give us a true. We really need to see what happened. And the only way we have access to the actual number of lines is when we add the text, but we're not always going to be adding the text. So what am I wanting? How do I want to do this? I think for now, we will just intercept the text queue. It's not, yeah, we're going to have to do a few things. That's too bad. What am I on here? 47 minutes. I gotta shut this down soon. So let's, not even going to get into a runnable state today. Oh. Let's say a call to fake text dot add text string that contains expected lines until transaction, and then we're going to say must have happened. Oops. So it's a very nice kind of API that Fake It Easy has created. You can read it as an English sentence. So a call to this that contains that must have happened. So this is just going to look to make sure that we're adding the text with the expected lines until transition. Yeah. It's not so great. It's not that testable because we're not doing anything. We're not returning anything. So it's a little unfortunate. And even then, this is only going to show up if it's less than 10. So if I take this away, so it always adds the text. Yeah, this is still going to just totally crap out, I'm sure. We can comment all those out. We can go to our test explorer and we can run all these tests and see what happens. I expect almost all red X's. Actually, 10 of them passed. That's curious. Why? 5 lines until transition. This is what it did. This is 09. See, and these could be my mistakes as well. So if you start at level 9, you're currently at 105 lines. You are now in level 10, but your speed increase is not going to happen until 13. So yeah, that is a mistake. Yeah, so that is wrong. So that one happened fine. Actually, this is probably an issue. I wonder if it's an issue because we're using... Oh, you know what? We do need a setup. The issue is these fake things are being, they're only being generated once. And so when we assert calls to them, we're really not doing what we expect to do. It's looking at like the history of all the tests that passed. All the test runs instead of just the current test runs. So, hold on. What am I doing? Yeah, we got to remove this and this and this. So in NUnit, any method with a, annotated with a setup will be run for every test. So we'll just recreate our fake objects. Oh, and they can't be read only anymore. Fake screen reader equals. Okay, fake color checker equals a fake color checker. Screen. There we go. I don't expect this to have changed anything, but you never know. Yeah, so still the 6 failed. This time this failed because it didn't it only found 10. So yeah, so that's wrong. So we have a few tests that failed, but now we can write code to make these tests pass. And I guess that's what we're doing next time. Man, this is taking a lot longer and it's a lot more complicated than I thought. But now that we have tests we can run, we'll fix this because all of this is crap. Yeah. Okay. Anyway, thanks for joining me. Have a good day, and we'll see you next time.